In this video, let's look in more depth at what a demand-driven planning protocol for Case D would entail. A demand-driven planning process like Case D tries to overcome weaknesses in top-down supply-driven programs in two ways. First, communities must make an informed choice as to whether or not they want to participate in a new rural water supply program. Second, engineers and others supplying the program's water, sanitation, and hygiene services must adapt to the decisions of local communities. This requires that central government provide local communities with the information they need to make an informed choice. Suppliers need to present communities with options and then design water systems that communities want. In other words, the engineers involved no longer simply follow a design blueprint provided by central government. This figure provides a sketch of the flow of information and money in a Case D demand-driven planning process. Here, the central government has three roles. First, to design the program rules. Second, to provide local communities with information about these rules. And third, to provide any subsidies in accordance with the program rules. Local communities must decide whether to participate in the program or not. Then, they must decide on the wash services or service level that they want, consistent with any cost-sharing rules detailed by central government. Finally, a local community may have some decisions to make about specific institutional, ownership, and pricing arrangements that it wants. Subsidies may flow from central government to those communities that decide to participate in the rural water supply program. Alternatively, central government may contract with suppliers directly and pay for the wash services that a local community decides it wants. These wash services must be consistent with the program rules. The central government needs to design 5 main types of program rules. The first type of program rule concerns eligibility. This determines which communities are eligible to participate in the rural water supply program. The second type of program rule specifies the technological options that are on offer. That is, what choices does a community actually have? The third type of program rule concerns cost sharing. How much will central government pay and how much will local communities pay for different technological options? The fourth type of program rule specifies the property rights regarding ownership of any facilities constructed, and the fifth rule is about financing. This may involve a mix of grants and loans. These 5 types of program rules may be designed in collaboration with a donor and in consultation with community leaders, or possibly both. Now let's discuss these 5 types of program rules. More communities should be eligible to participate in the program than there is funding available. Because communities decide for themselves whether to participate in the program or not, they reveal their demand for improved services by their decision. The result of the process is a new procedure for village selection. This is quite different from the random selection process we saw in Bolivia for assigning communities to participate in the program. In most circumstances, a community should be free to choose a higher, more expensive level of service if households are willing to pay for it. For example, the central government may specify a certain subsidy per person. If households want a higher level of service than can be built with the subsidy, then they would need to pay more. However, for a variety of reasons, the central government may want to limit the technological options a local community can choose. One reason may be local or regional water resource constraints. Another reason may be public health concerns about sanitation. Higher level government may want to insist that some sanitation facilities be installed if piped water systems are going to be constructed. The central government may also choose to restrict subsidies to water and sanitation infrastructure and not allow a community to spend funds on other priorities elsewhere. But the important point is that the central government program rules clearly specify what type of projects are eligible for subsidies. The cost-sharing formula for local communities may be constructed in different ways. Central government may pay a percentage of the capital cost of different service levels, or it might set a maximum capital subsidy per household or per community. A key question is what level of cost sharing will elicit optimal investment choices. As I mentioned previously, in demand-driven rural water supply projects around the world to date, the share of capital costs paid by local communities has been extremely small. Another type of program rule involves assigning property rights to the constructed capital facilities. Does the central government transfer ownership to a village water committee or to local government? If so, when does this transfer take place? Is the transfer contingent on the community doing something? How are households informed of this transfer? Does central government retain ownership in case the facilities are captured by local elites at some point in the future? Finally, it is important to emphasize that a demand-driven process has important implications for how engineering design work is undertaken. When design engineers work for central government or donors, they typically pay little attention to communities' priorities about levels of service and where water facilities should be located. But if communities are paying for part of the bill, design engineers will pay attention to these things. Communities may ask for multiple designs with associated cost estimates so that they can better understand what their options are. And because communities are paying, engineers and suppliers should be more creative in finding low-cost solutions that can match a community's preferences and budget. Early in my career, I was conducting a research project in Haiti with an NGO, and I worked with a young engineer who was designing water projects for rural communities. He would do this at night after a few beers. He would say this community needs 3 hand pumps because, and then he'd give a reason, and this community can afford public taps. And he would go on deciding what systems he would build in communities based on his personal judgment. The demand-driven planning approach is designed to avoid this kind of ad hoc decision-making by outside technical experts. I'd like to draw an analogy between a water design engineer working within the context of a demand-driven planning protocol and an architect designing a house for a client. Imagine an architect is designing a house for you. She must listen to what you want, what style of house, what size, how important to you are things like energy savings and what the view will be from your windows. Similarly, in a demand-driven approach, a design engineer needs to understand the level of service that a community desires and what attributes of a water supply system are most important to the community. For example, does the community want 24/7 service? Do people in the community mind the smell and taste of chlorine in their water? When an architect builds a house, she also needs to know the household's budget. Similarly, a design engineer needs to know a community's budget parameters. There's no point in designing a piped water and sewer system if the community, even with the subsidies available, simply can't afford it. In a top-down centralized planning protocol, design engineers typically work in large cities, often in the capital. This is where the donor and national governments are located because that's where the money is. One of the objectives of a demand-driven rural water supply program is to get the water design engineers out of the capital and working more closely with local communities. They can then design systems that are closer to what local communities want and can afford.